How's it going, guys? Happy Friday. And this is our lesson 3 of week 1 of during the school closure. So today we're going to finish off the higher level functions part, and then on Monday we'll take about 5 minutes or 10 minutes to correct the revision exercise from this, and then we will go on and we will look at something new, a bit of arithmetic. So on to a new chapter come Monday. So we're going to correct the homework. 14.2 and 14.3 from the last day. Make sure that you have the work from Monday and Wednesday uploaded, and I'm going to go through and correct that on Friday night and Saturday night. So there'll be marks on your exercises come Monday, but it's important you have those too. The questions that I'm going to give you today, so this will take about 20 minutes, 25 minutes to go through the homework, but that's the last. There's no more concepts to take on in functions. It'll just be going through revision exercise, but it'll be part of the lesson today as opposed to the homework. So I'll throw up the solutions, but you won't have to do anything for the weekend because the week's been long enough for you, I'd imagine. Okay, so we'll go back to the OneNote and we'll have a look at the questions from for the homework. And the first one's there. So I gave you two. I gave you exercise 14.2 questions 2 and 3, and we'll start with that. So what they want you to do there was graph the function x squared minus x minus 4. So you could do that in your sleep at this stage. So there's your function there, and there's your table there. And they want you to estimate then in part A, part B, part C, and part D. So I'd imagine no one had any bother working at the y values for that function. So we go straight over to the solution, and we work at how do they figure out values of f of 1.5. So here's our solutions over here on the right hand side. So here's what the graph that you drew should look like. That's what the graph should look like. But they're asking us to find, well, where is f of 1.5? So if we go on our graph there and we go to where x is 1.5, which is up here, f is 1.5, and as before we go down to where it touches the graph and in, and there is where f 1.5, and our answer there is 3.25 or minus 3.25, because we're in the minus y there. So minus 3.25. Very good. Okay, back over to the question. What else did they ask us to do? The values of x for which x squared minus x minus 4, so where our function equals 0. So where does our function equal 0? And let's go back over to our solution where they say our function is equal to 0. So if they mean where does it equal 0, they mean where does it cross the x-axis. So we can see that our graph crosses the x-axis here and here. So in the solution they're saying, right, the graph crosses f of x crosses the x-axis or equals 0 at minus 1.6. So our first answer here. And also crosses it over here at 2.6. So there's two values where our function is equal to 0, at minus 1.6 and at 2.6. The part C and D are related to part B. The values of x for which x squared minus x minus 4 is less than or equal to 0. You're saying, well, where is our function less than or equal to 0? Well, if we look at our full function, obviously the function is the full curve. The curve starts there and ends over here. But our function is greater than 0 here, and it's greater than 0 all the way up here. Our function is less than 0 down here. They're asking us then, where is our function less than or equal to 0? And our function is less than or equal to 0 everywhere from this point here to this point here. So the way they word the answer is x is greater than 0 between minus 1.6, our first point, and 2.6. So the red part of the graph there is where it's less than or equal to 0. And the last part I think is pretty much the same idea. The minimum value of f of x. So if we have a look at f of x, where's the minimum value? So our minimum value is down here. This point here where the purple line is there. At minus, and they put it down as minus 4.25. So our minimum value is minus 4.25. Okay. The next question then, they actually give us a graph. So question 3, they give us a graph. And they say, well, the function f of x is minus 0.25 plus 4, and g of x is 7x minus x squared. And they're graphed in the domain. Now, and we're not too worried about that now because they've already drawn the functions for us. They've told us that here, okay, well, g of x is this nice quadratic curve, and f of x is this straight line. So f of x is a linear function. So we have the two functions drawn for us there. And they're going to ask us a couple of questions based on the graph they've given us. So what they're asking is, what is the maximum value of f of x? We know that, well, the top, if we go back up to our domain, our top value is 7. That's as far as we can go. So we can sub in 7. So if we go and we say, right, well, if f of x is our function, well then f of 7 is going to be equal to 0.25, because remember what our function is up here. So f of x is 0.25x plus 4. So f of 7, instead of x, we're going to sub in 7. Oops. Plus 4. When you multiply that out, that gives you 5.75. And if we look at the maximum value of f of x over here on our graph, we can see there that here is where the maximum value of f of x is there. And that's roughly, isn't it? If we go out from 5.75, that's roughly correct. So I can read that answer from the graph roughly, but using algebra I can do it much more specifically. I can get bang on 5.75. Part B of that question, use the graphs this time to estimate the value of x where f of x is equal to g of x. So f of x is equal to g of x where the two of them touch. So f of x touches g of x here, and it touches it here. I'm just going to get rid of this stuff here because it's in the way. So it touches it there, and it touches it there, and we're looking for the x value for that. So we can bring that down from where they touch, and we can bring it down from where this touches here. And the answer they give us over here in the solution, over here in the solution, is a 0.7 and 6.1. So we look at what I've drawn there. Yep, somewhere around 6.1 and somewhere around 0.7, just slabs. So my line's a bit crooked there. But if you go straight down with a ruler, you're going to get 0.7 and just over 6. We go on then, all these questions are related. Use the graph, so part C, use the graph to estimate the values of x for where f of x is greater than g of x. Remember we got this greater and less than. So where is f of x greater than g of x? And we can see that from between the point, see the two circles that I've drawn in that answer here. So everywhere above that, so I'll do a different color, I'll go yellow. Everywhere above that. So where x is less than or equal to 0.7 and where x is greater than 6.1. So that is going to be, so your answer is going to be written like x is less than or equal to 0.7 or x is greater than 6.1. So all in the middle there, this whole middle section, the yellow part, is where f of x is going to be greater than g of x. And the opposite then is use the graph to estimate the value for which f of x is less than or equal to g of x. So that's just the opposite really. So for the last part of this, you're just going to be that, well, if we stick x in the middle, this is part D, well, we know that between 0.7 is where they cross. So if less than or equal to x is less than or equal to 6.1. So it's the opposite. So the 2 points where they meet is where they're equal. And then g of x is greater up here, g of x is less down here. So we can work out then where f of x is greater than g of x, or where f of x is less than g of x, or they want to word it differently, where we can work out where g of x is greater than f of x, or where g of x is less than f of x. Just be careful of the way that they word the question. Okay, and that's your first two questions. Any questions on those, of course, send me an email, and I'll check your work in your homework section of OneNote come Friday, Saturday night. Okay, the other one I asked you to do is all based on these exponentials, and this is it's more just it can confuse you because you're doing 3 to the power of minus this and so on and so forth. But it's still the same. There's no, the rules are still the same. We still have an input, we still have a function, and we still have an output. So there's no difference in doing this. So I gave you a couple of these to do. We started on question 4, and the hardest part, because you're sick to death of graphing these and drawing out the function table, but the hardest part of this was actually figuring out the y value. So we'll have a look at the first one here now, and this is y is equal to 2 to the power of 3x. Okay, they give us our domain up the top here. Our domain is minus 2 to 3, so we're going to be subbing in minus 2, minus 1, 0, 1, 2, and 3. But if we if we start doing that, minus 1, minus 2, 0, 1, 2, 3. So that's the handy part. We're going to be looking for our y value. Our function in the middle is the bit that that can catch it out. So our function is exactly as they give it to us. 2 to the power of 3x. That's our function. So 2 multiplied by 3 to the power of x even. 2 multiplied by 3 to the power of x as it's written there. So I'm gonna write these out. Before I do any maths, I'm just gonna write them out exactly as I would have done if it was a linear or a quadratic function. So I'm gonna write 2 multiplied by 3 to the power of minus 2. That should be a 2, and that should be a 1. 2 by 3 to the power of minus 1. 2 by 3 to the power of 0. 1 by 3 to the power of 1. No. 2 by 3 to the power of 1. 2 by 3 to the power of 2. And 2 by 3 to the power of 3. And you multiply them like that. And I suppose this is where the calculator really comes in handy. And I'm going to calculate them as I do these as well. So 2 by 3 to the power of minus 2 on my calculator is coming out as 0.1. 2 by 3 to the power of minus 1 is coming out as 0.33. But what I've forgotten to do, obviously, is multiply by 2, which I should have done. So this is going to be 0.2, and this is going to be 0.66. 3 to the power of 0, anything to the power of 0 is 1, so 1 by 2 is just going to give us 2. 3 by 2 is going to give you 6. 3 squared is 9 by 2 is 18. 3 by 3 is 9 by 3 is 27 times 2 is 54. Okay, so there's our y values there. So obviously your I suppose difficulty and the mistakes are made is these ones here. And that's why they give you these exponential graphs, but you have a calculator, so make sure you use your calculator. Don't try to be clever, and 3 to the power of minus 2 gives you 9. It doesn't. It gives you a much smaller number. Okay, so that's the hardest part of that question done. Then you're just going back to as per normal. You go over to the solution now, and you get a graph like such. Okay, so they've just graphed. So here's your couples. Here's couple 1, there's couple 2, there's couple 3, and they've put them into an XY axis, and they've got a graph like that. Like I said, these exponential graphs are not U-shaped, N-shaped straight lines. They're all over the place. They're quite kind of strange, so they can go in all sorts of weird shaped curves and so on. So that's question 4. Don't ask anything else in there? No, they don't. Question 5. Question 5, they give us a graph. So question 5, we'll zoom in on here. I'll just get rid of this, this, and this. Keep it out of the way. Question 5. They use the graphs below here, estimate the range of values for which f of x is greater than g of x. So f of x is your red, and g of x is equal to your green. Just because it's not a curve in a straight line doesn't matter. we know, even before I even look at f of x, I know that f of x is greater than g of x from here all the way down to the line. And I know f of x is greater than g of x here as well. I know g of x is greater than f of x from here up there. And I know g of x is going to be less than f of x, everything under that. Right, so where is f of x greater than g of x? My two key points on all of these graphs, even before I look at the questions, is going to be here and it's going to be here. Those two graphs there, where f of x is equal to g of x, even though I don't tell it, even though I don't ask that question here. So 5a, f of x is less than g of x at the point we said. So somewhere here. Just do a different color so you can see. Somewhere there, just below -2. In the solution they say, -2.1. So just after 2. So this one here is going to be -2.1. And over here as well, if I look at it, it's this point here. So if I go down to the x-axis, looks 0.6 or 0.7 on the solution, they say 0.6. So -2.1 or 0.6. There's my two solution. So everywhere below that. And the last one then is the range of values for which g of x is greater than or equal to f of x. So where is g of x greater than or equal to f of x? Well, if we put x in the middle, as per the last exercise, is going to be greater than or equal to at -2.1, less than or equal to at 0.6. So they're going to say everywhere in between. So g of x is going to be greater than f of x. So what they're asking you to do is basically get a different color. From here down as far as here. Okay, right, and that's question 5 done for us. This question 7. Graph the function in the domain -2 is less than or equal to x is less than or equal to 3. So we have it's just another exponential function. I put this one in because of this, but really it's exactly the same. They want you to do a table out for f of x, which is 2 to the power of x. So it's just putting in 2 to the power of -2, 2 to the power of -1, 2 to the power of 0. 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, and the same for g of x. So instead of the x, you're just subbing in the domain again. So we'll just have a quick look at the solution to that. So you're going to draw the graphs. So you have two graphs, and then where is f of x greater than g of x? So if we go over to question 7, there's your graphs drawn there. And on that graph, where is f of x greater than... Where is f of x greater than g of x? And if we go along and have a look at the graph, well, f is your blue line and g is your red line. So we say, right, well, here's the point. Here's our key point where the two of them cross. So if we say, right, well, there's our point. So everywhere after that, f of x is going to be greater than g of x. So if we get our line and we draw our line down, somewhere around 1.8. Oh yeah, there we go. So the answer is 1.79. So same every time. You just find out where they meet, and everywhere after that, one is greater than the other or one is less than the other. Okay. Now, the last one was this one here, and you'll see that they use these curves a lot, these exponential curves, if they're looking at growth that is out of control. Like the COVID crisis, they use these graphs all the time for all the different hospitalizations and ICU rates and so on and so forth. So they'll do those, use these graphs all the time. So what they want you to do, on June 1st, on the 1st of June, a type of algae was introduced to Loch Arrow Lake. It grew and spread so that T days, the volume of water containing the algae was given at AT is equal to 2 to the power of T. So there's our function hidden in there amongst that paragraph, where A is the volume in meters cubed. That's fine. Draw a graph to show the volume of algae in the lake after the first 6 days. Okay, So he wants to draw a graph after the first 6 days. So our graph is going to look something like, well, our function is 2 to the power of t. After the for the first 6 days, so we're going to have 0 days, 1, 2, 3, 4, 5, and 6 days. And then this is obviously going to be your x, and this is going to be your y over here. I'll just draw a line, and so on and so forth, like so. So we're going to have 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, 2 to the power of 5, and 2 to the power of 6. And when you work all those out on a calculator, that will give you your y values over here. And that will be your exponential graph. So that is the graph this graph here. Like so. Okay. Now, also on 1st of June, a pollutant began to seep into the lake. Right. Never good. The pollutant spread so that after t days, we don't know how many days, the volume of water containing the pollutant was given by a different function. Pt is equal to 30 plus 40, where P is the volume in meters cubed, the same way the same way A was earlier on. Use the same axes and scales, draw the graph of P over the first 6 days. So you're going to do that exactly the same way. The only difference is that your X values are going to be 1, 2, 3, 4, 5, and 6. Your function is just going to be different this time. Your function is going to be 30 plus 4t. And you're going to draw your graph like that. And you're going to sub in, I'll do one for you, 30 plus 4 times 1. Down here is going to be 30 plus 4 times 5. And that is going to give you your y value over here. So you're going to have a set of couples for your curve up the top, and then you're going to have a set of couples for your line. And then in the solution then, that gives you the second, so the second function table we just did there gives you this line here. And at this stage, you could do these all day long, these tables, and working out how to draw graphs. Doesn't matter if it's an N shape or a U shape or a straight line or an exponential curve. It doesn't make any difference. You're well used to doing that now, and you showed that in your exam. The question, I suppose the only difference in ordinary and higher is these kind of questions here at the end. This kind of question here. After how much time will the volume of water containing the algae equal the volume of water containing the pollutant? And give your answer correct to 6 hours. Okay, so if we go over to our graph that's drawn, and we look, well, where is the algae going to be? Are they going to be the same? Well, wrong graph. What we do, we look as we've always done in the last couple of questions, that the most important part is, well, it's going to be here. And we're looking at time. So time, remember, is the amount of days. Down here is days. So we're wondering how long a days is the amount of pollutant going to be equal to the volume of water. And you draw your line down as they've done in the solution. And some, like what, 5.8 days, something like that, or five days that I give in the solution, 18 hours. So nearly 6 days, 5 days and 18 hours is what they're given. Okay, and if you wrote 5 days and 20 hours, you know, you're not going to be wrong. If you wrote 5 days and 15 hours, you're not going to be wrong. Somewhere around that. Okay, and Sinead on homework. But I do want to see your, about half of you have it already uploaded, but I do want to see your effort to the homework that I gave you on Monday in lesson 1 and the homework that I gave you on Tuesday in lesson 2. It's important I know that you're able to do higher level function questions before we move on, because that's going to be question 1 come summertime exam. It's going to be on higher level functions. So don't let it pass. Rewatch the lesson if you need to. Do the questions. Upload them to the homework section of your OneNote. I'll be correcting them Friday and Saturday night. Okay. Last thing I want you to do, and this is not homework, this is for the second half an hour of your class today on Friday. And this is just the revision exercise. It's a mix match of all the different types of higher level functions questions. And I've just highlighted 4 of them. So I've highlighted question 2, question 4, question 9, 2, 4, 7, and 9. So it's a bit of a mix mash of the different types of functions questions. and I would like you to do them for the second half an hour of today's class. It should take you no more than 30 minutes to do the 4 questions. You don't have homework for the weekend. You don't have to upload these to the homework section of your OneNote, but I would ask that you do them and make sure you upload the other homeworks. Would you also do me one favour and vote on the poll? Are you happy with the videos, or are you, would you rather we do one of those conference calls on Schoology every day that we have maths? But let me know. It doesn't make much of a difference to me. The benefit of the videos is you can watch them back and then ask questions later. But if you want to ask questions in person and do it like we would do during class, in a live lesson, then that is possible too. So email me if you have any issues or questions or queries or suggestions. I'm here all day tomorrow. If not, have a lovely weekend. You're off Monday, so we've no class Monday. So I will get working on the arithmetic, the next topic, and have those notes ready to go for us on Wednesday. Okay, mind yourselves. Take care. Bye-bye.